In this video, we're going to be looking at some examples of elementary vector operations. We're going to be dealing with a couple of vectors that are in R3. Yeah, see? Vectors. So vector v is going to have components 4, -6, 3, and vector w is going to have -5, 2, 0 for its three components. What I'd like to do is find the following based on these two definitions. So we'll start with very simple and straightforward vector addition, vector v plus vector w. So that's going to be the vector with components 4, -6, 3. We will be adding to that the vector with components of -5, 2, and 0. Vector addition is pretty straightforward. We take the corresponding components and we add them together. So the 4 goes with the -5, so 4 plus -5. The -6 goes with the +2, -6 plus 2, and the 3 goes with the 0. Once we simplify those three components as much as possible, 4 plus -5 will be -1, -6 plus 2 will be -4, and finally 3 plus 0 will be 3. No problem. Now, a very similar operation for part B is vector subtraction. This is where, once again, we'll be starting with these two vectors, v and w. So we'll take 4 at -6, 3, and we will be subtracting the vector -5, 2, 0. Now, two schools of thought on vector subtraction. One would be very much like vector addition. We simply take the corresponding components and subtract them. Or we could treat this negative as a -1, distribute the -1 like scalar multiplication, and then add the results together. I don't feel the need to go unnecessarily complicated where it's not necessary to do so. So we'll just go ahead and subtract the corresponding components. So, corresponding components, 4 minus -5, -6 minus 2, and 3 minus 0. Once we subtract these corresponding components, 4 minus -5, same as 4 plus 5, -6 minus 2 will be -8, and 3 minus 0 will be 3. No problem. Next up, an example of scalar multiplication. We're going to take 5 times the vector v. So 5 times vector v, which is 4, -6, 3. And definition of scalar multiplication, we will be multiplying all three of these components by 5, whatever that scalar happens to be, in front of the vector. So we'll be doing 5 times 4, 5 times -6, and 5 times 3 for the vector 20, -30, and 15. No problem. Finally, anytime you do a combination of scalar multiplication, vector addition, and vector subtraction in whatever quantity you want, we will be doing what is referred to as a linear combination. This linear combination, I'd like to do 4 times the vector w and subtract 3 times the vector v. So first thing we'll do is actually write that down. So 4 times vector w, that'll be 4 times the vector -5, 2, 0, minus 3 times the vector v. The v is once again 4, -6, and 3. Now, when it comes to combinations of multiplication and subtraction, like we see here, please keep in mind the order of operations. It is multiplication that comes before addition and subtraction. So let's perform our scalar multiplications first. Distributing the 4 to each of the components of the vector w, we'll get 4 times -5, which is -20, 4 times 2, which is 8, and 4 times 0, which is 0. Minus, we'll go ahead and distribute a +3 through here to keep this as subtraction. 3 times 4 will be 12, 3 times -6 will be -18, and 3 times 3 will be 9. Then we'll be subtracting the corresponding components to get this vector subtraction. So -20 minus +12, that'll be -32. 8 minus -18, it's the same as 8 plus 18 for 26, and 0 minus 9 will be a final answer of -9 for that component. So this linear combination will be -32, +26, and -9.